Hello everyone, welcome to our webinar. Sorry to keep you waiting. My name's Bara. I'm a marketing communication specialist here at ACDLabs and I will be your host today. So our company, ACDLabs, we are based in Canada, Toronto. We develop software for vendor neutral processing and data management. We help scientists extract answers from analytical data quickly and with confidence, and provide the capabilities for you to share the knowledge with the rest of your organization. We have sales and support offices in the UK, Germany, France, and all across the globe, really. The company turned 30 this year. We were founded in 1994, so it's been a busy 30 years for us. We have 200 employees supporting customers across the globe at almost 5,000 different R&D organizations, including many different academic organizations. In terms of Spectra's processor and what it offers you, I'm sure you're all familiar with the hassle of analyzing your chemical data across different software and different platforms, especially if you use loads of different techniques like NMR, IR, LC, MS, etc. So the big benefit with Spectrus processor is you can use one application for all your spectral processing and analysis and reporting as well. So the software does all in one kind of approach. The Spectrus processor in particular supports all major techniques from most major instruments and vendors, including NMR, chromatography, mass spec, IR, and other data as well, such as UVVs, TGA, DSC, etc. Meaning you can quickly and easily interpret all your data with confidence, as Tom will shortly demonstrate for us with sound this time. For academics, Spectrus processor offers quite a benefit in terms of learning for students, so it can support students learning about structure interpretation and structure verifications, particularly with NMR. It's really useful from that aspect. For research scientists, the software can help accelerate your decision making with regards to what happens next in your reactions. So without further ado, today's webinar is looking at the desktop application of Spectrus processor as well as Spectrus processor JS, which is our browser-based data analysis. And once again, our presenter today is Tom, who's our application scientist based in the UK. So Tom, over to you once again.
Thanks, Barrett. Okay, just bear with me while I share my screen again. Okay, so hopefully everybody can see my screen and they can hear me talk. So let me turn off my webcam so we can just focus on the data shown. So in today's webinar, we will look at two bits of ACD software. The first is the desktop-based Spectrus processor, which will allow multi-technique processing and reporting. So we can bring in data types from all different instrument vendors. The software is vendor agnostic, and we can process it and view that data and report that data from one place. So it's a really good tool. It cuts down on the need to train and learn lots of different software. And if you're handling lots of different types of software, so NMR, IR, LCMS, you can view that in one place and process that in one place side by side. So it's a really good, cool tool. In the second half of the webinar today, we'll look at Spectrus Processor JS, and this is for browser-based processing. So this means that anywhere that you have access to a web browser, you can view your analytical data, process your analytical data, and then make decisions from your analytical data. And in today's webinar, we're going to highlight the features to be able to do synchronized 1D and 2D NMR processing with this piece of software. So we'll start off with the desktop-based Spectrus processor, and I'll move now to the software. And what we can see open here is an already processed LC UV MS dataset. But also at the top here, you can see I have other datasets open. We have NMR, GCMS, IR data as well. So we can see and view these all in one place, and we can change the layout as well. So we can highlight more than one spectra on the same screen. So we can have one sample, but many types of acquisition. We can have all that in one nice, convenient place for us to work with. Starting off with this LC-UVMS dataset, you can see there's already been some processing applied to this. The peaks have been integrated and named, and you can see that information in tabular form down in my table of peaks down here. Notice this is nice and interactive, so if I hover over the different rows in my table of peaks, it's highlighting in the chromatograms where they are placed based on the retention time. I have my TAC, my UV data, and my TIC for my mass spec data here overlaid. And if I click through the different peaks, you can see underneath the MS under that particular scan will update, and I can also see my component mass spectra, which is the mass spectra of the structure taken from the combined MS scans across the width of the particular peak. And then just finally down here in my table of components, you can see all the structures that have been assigned to this data set. Now we'll come back to this data set at the midpoint of this webinar to show you in a bit more detail of how we process this and got to this endpoint. But what I'll show now is the ability to report out of Spectrus Processor. And that's a one-click button push. So we can use this report tool here, and that will report out to a predefined template that I set up in ChemSketch. So that will report out, and we can see this is the outputted report from that data set. And this is fully customizable. So we can choose the different fonts, different images. You can put your own company logo in here. You can choose what you want in the tables, how you want the tables displayed. You can see I've got my individual structures and their individual mass specs in this report as well. A really nice feature is this Zoom Spectra tool. So we can click this and we can zoom in on a region of interest in our chromatogram or our spectra, and then we can expand that for the report. So we can zoom in and see an area of interest that we want to highlight to the reader of these reports with an easy button click. When you're happy, you can export this report to PDF. So just an example here that I've already prepared, that can be exported to a PDF document. So as I said, we'll come back to this data set in a little while to show this in a bit more detail. But before I do that, what I want to do is give a quick sweep through doing some basic data processing and structural verification with a range of analytical techniques within Spectrus Processor. So we'll start off with NMR, and here I have a proton NMR dataset, and I've already associated this structure, which is catechin, with the dataset. You can see I've already carried out my Fourier transformation, my baseline correction, and I've already referenced my solvent, which is DMSO, to the correct chemical shift. But now what I want to do is start picking my peaks, defining my integrals and multiplets within this dataset. And within Spectrus Processor, you have full manual control over how to do that. So we can do this all manually. But the software also offers some very nice automated tools, which we can do this process within a couple of clicks. So this one is up here. It's called Spectrum Analysis Auto. So with one click, you can see it's picked my peaks, it's defined my integrals, and it's defined my multiplets across the spectral region. And the next thing I want to do is start assigning the protons of my structure to my spectral data. Again, you have full manual control in the software, but the software also has some very nice automated features that will speed this up greatly. So this is the assignment auto button here. So I click this, and then what the software is doing in the background, it's going to predict a proton spectra of this structure. And then it's going to compare that predicted spectra to my experimental data. And the closeness of match is what determines this match factor score here for the entire spectra. So the match factor is a score from 0 to 1. So a match factor of 0.97 is very good. So we can use this tool to help us with that structural verification for NMR. I'll move on now to some GC-MS data. So like we saw in the LC-UVMS data, we have our chromatogram panel here. We have our mass spec under the point of the cursor. So I can move between the peaks here and look at the mass spec under that peak. But what I can do is then add a structure to my chemical structure pane and then I can assign that to a peak, a particular retention time, and the software can help me get my assignment correct. So within this structure pane, we can start to draw in a chemical structure. So I'll draw in a benzene, and note when we do this, and as soon as we start drawing the structure, the software extracts an ion chromatogram for the molecular weight of that particular structure. So we can see in real time what's underneath these peaks. So as I continue to draw this structure here, you'll see this XIC will update. And I'm looking for this particular structure here. So this structure here has now been added as a line in my table of components. I've not yet assigned it to a retention time, but the software is giving me an idea of where it sits in my chromatographic data from this XIC. And then to assign it, I can click and drag to this window. The green box there is giving me an indication that there is a very good MS match. So the MS match is a function of the predicted isotope pattern based on the molecular formula that we've inputted and the experimental data. So if I zoom in here to my component mass spec, you can see the red lines are the predicted isotope pattern. The black lines here are the experimental data, and it's the closeness of match that gives me an indication of this score in MS match here. So it's another quite useful tool for doing structural verification. The last thing that I want to show in this kind of sweep through different types of data sets is infrared. So we have here an infrared spectrum. It's in absorbance mode, but if you're more used to seeing your peaks coming down from the ceiling across percentage transmittance, you can change it to see that as well. And first, we'll do some basic peak picking processing by using this peak level tool. So this will pick the peaks by level here. And then we can go up here to our workflow bar to click on this assignment tool. So with this activated, we can go to our chemical structure window. I've already had this structure drawn in, and we can click on a fragment, and the software will then suggest to us where we should assign that fragment in the spectral data. And if I hover over an area here, it will also give me an indication of the vibration mode going on there, and it will label the spectra accordingly. So we can repeat this process throughout. If you don't agree with any of the assignments, you can, of course, change them manually. So you do have full manual control when you're doing this. And with any of these data sets, you can report out to either a standard template in the software, or you can design your own and use that again and again. So hopefully that's given you an overview of how we can use the software with some different types of data. We can't just handle NMR, GCMS, IR, LC, UVMS. There are other data types that the software can handle, things like TGA and DSC. And if you look on our website, you'll find a full extensive list there. Let's move back to our original data set now, and we'll move to this file here, which is a cleaned up version with no processing attached. So we'll show you in a quick overview of how we got to this endpoint over here. So this is our unprocessed data. You can see I've got my TAC and my TIC and my MS panel here. I don't currently have any chemical structures assigned to this data set. So I want to carry out some basic processing. I want to integrate these peaks, and I then want to add some structures to the data set and then assign them to specific retention times. So the first thing that I might want to do is make sure I'm excluding any of, say, the gradient effects or the solvent front effects from my chromatographic data. And I can do this quite easily. There's a few different ways you can do it in the software, but probably the easiest is clicking and dragging these gray lines from the end and excluding. You can, of course, exclude regions in the middle as well. And then we can start the process of integrating our peaks. Like with the other data types, you have full manual control. You can do this by peak level. This icon here will let you do it completely manually. You can pick the individual peaks, delete peaks, split peaks, change the width, change how the intersection with the baseline. But what I'm going to show you is the really useful signal analysis auto tool, which will do this automatically with the click of a button. And if we look in some of the other options here, you can see we can control how this automated tool is doing it. We can set things like the signal to noise ratio, the minimum area of the maximum height, and we can change how the integration is performed. and then you can save these parameters and load these parameters back up in future for when you need to use them. So now that we have our chromatographic data nicely integrated, the next thing that I want to do is add structures into this data set. There's a number of different ways of doing this. Like we saw in the GCMS data, we can draw them individually into the structure pane. We can also import things like SDF files directly in. The way that I'm going to show today is that we're going to go to the ChemSketch drawing package with this button click up here. And I've used the full functionality here of ChemSketch to pre-draw out these structures here. You can also bring in things like smile strings and inchy strings as well, and it will generate the structures from there. With your structures drawn out in ChemSketch, we click this button down here to add those structures to the active data file. And that will then add them to my table of components. And you can see we've got an extracted ion chromatogram of this particular component, which is ticked here. And we can cycle through these. We can show multiple XICs, and we can cycle between showing individual or all. And this can help us with assigning these structures to our retention times. Note, even though the software has not yet assigned these to a particular retention time, it's already giving us an indication of what the MS match score will be. So that's the predicted isotope pattern versus the experimental isotope pattern. And now if I click on my table of components and click and drag, it will highlight to me where it thinks that structure is. And we don't have to agree with the software, but the software here is giving us a really useful tool to speed up that assignment of structures to particular peaks in our chromatography. We could repeat this step. We can bring in more structures. We can do some more processing on these data files. But when we're happy, it's a one-click report to the predefined template that I'd already set up. And this will open up in ChemSketch. And we can see we have the same type of report as we saw last time, just with fewer components this time, but it's been reported out to that predefined template. So that's everything I wanted to show with the desktop version. Just to summarize this part, we showed how to look at our different data types within Spectra's processor, and we had a quick sweep through doing some structural verification with different types of analytical data, and then a more in-depth look of how we carry out the actual peak processing, adding structures, structure assignment, and then reporting. Okay, so I guess the second half of the kind of software demonstration from this webinar is to look at Spectrus Processor.js. So we're moving on from the desktop-based Spectrus Processor to browser-based Spectrus Processor.js. And the big advantage of a browser-based processing software is it can be accessed from anywhere that you have access to a web browser. This means you can have a look at your data, you can process your data, you can report your data, you can make decisions from your data with the flexibility of having access to that anywhere. Processor.js can also handle XC UVMS datasets, but for this demonstration, we're going to focus on the synchronized 1D, 2D NMR processing. So let me move now to the software. And the browser that I have this in is Google Chrome. And you can see I'm going to start with an already processed NMR dataset. So let me take you through some of the features of what we're looking at. So currently in my Spectral window, I have a proton spectra of this structure here open. But down at the bottom, you can see I also have a carbon. And I also have a HSQC depth spectra as well. Let's just zoom in so we can see those peaks and HSQC depth. And we can click between the three, or if you have more, you have HMBC, you can have COSIs, you can have depth edited carbons, whatever you like in here as well. You can flick between them by clicking on the tabs down here. We can also set the view up so we can view these spectra at the same time, either vertically or horizontally, like so. So we have a lot of flexibility in how you use it. And the way it's laid out is that these are in kind of widgets. So you can click and drag and resize these widgets as you wish. You can make them bigger and smaller. You notice in some of them, we have some little tabs here. We can expand these. We can pull these tabs out. We can move them around. So it's very flexible in how you set this up. It's really up to you and your own personal preferences and how you view the overall layout of here. On the top left here, we have a spectral data table widget. So this is going to show us our spectral data. We have a structure widget here. So this is showing us the structure. The green circles here show that these particular atoms have been assigned to our spectra. And indeed, if it's all interactive, so if I hover over any of the lines in my spectral data table, you'll see if I flick between these two, you can see in the structure pane, it's highlighting where that is in my structure. And you can see in the spectral data in the red text, it's highlighting where those actual spectral lines are. And the same is true if I hover over the atom on the structure, I will get the same effect. So it's very nice and interactive. One really cool feature about this is that it automatically generates this multiplet report down here. So as you're processing your data, the multiplet report is automatically generated. So we can see it as well for carbon or proton. And what's extra nice is that you can change the formats of these. So we have some common journals in here, and you can change the format to match those as well. So that would be a huge time saver, not only a time saver, but can drastically cut down any transcription errors as well that you might find when you're doing that by hand. From Processor.js, we can report out easily, and we can go up here to this Pages tab, and this will open up the reporting function. So we can click and drag any of the items from the data set into this report, but just as a once over, I'll show you that I've set up a pre-made template, and this will be an example report here from our data sets. I'll show you later on in the webinar in more detail how we do this, but you can see for now I've got my carbon, proton, and HSQC depth, as well as some of my data tables in here. And then that can be exported to a PDF, like we saw with Processor.js. Okay, moving back to my data set, and I'll move now to the home page. This is where you'll see all the data sets that you have in Processor.js. I just have 2 at the moment, but you might see many more in here. And we'll change to the unprocessed data sets for this one. And we'll just let that load. So you can see I've got my proton, my HSQC, and my carbon-13. And I've not actually done any processing on here beyond the Fourier transformation, phase correction, baseline correction, and I've also done the solvent and reference as well. So these are all automatic buttons that will do these functions automatically. You can set it up to automatically do the Fourier transform, phase correction, and baseline correction by default when you open the data set as well. So let's show how we process a data set in Processor.js. So like we saw in the desktop Spectrus processor, we have some automatic tools to do this. If we click on this icon here in our workflow bar, this is the signal analysis one. And if I expand the options, you can see we have this auto dataset tool. So this will change that to tool A, which means it's an automatic process. And with one click in here, this will process all of the spectra in my dataset automatically. So if I increase that tile to 3 there, so we can see everything, it's done the peak picking integration and defining multiplets in my proton. It's found my correlations in my HSQC, and it's done my peak picking in my carbon spectra as well. Once we've done that, we can do the auto assign button to start to assign the protons and the carbons in my structure to my data. So that's one click, that's now assigned these particular protons. My spectral data table is updated, and my multiplet report has been created as well when I was doing that processing. If I switch up here to structure user data, then we can get that match factor score that we saw. But this match factor score is taking into account all of the spectra in this entire kind of dataset project. Let's undo those last 2 operations, and I'll go through some of the manual processing now. So to do that, we'll go down to our signal analysis and change that to manual. And this is where we can really see how the synchronized peak picking comes into play. Okay, so what we'll do, we'll zoom in on the aromatic region in my proton spectra. I'll zoom in a bit more. Notice it's synchronizing the zoom in my HSQC as well. And with the signal analysis button ticked, you can see I now have these buttons up here, which will let me do my manual processing. So it's a click and drag over the signals to define my integrals and multiplets. If I click up here with the red line above, it's not going to pick any peaks. If I click down here, it's going to pick a lot of baseline peaks. So I need to get the level of this peak appropriate for the signals that I'm integrating. And notice what it's done. It's integrated the signal in my proton, and it sent this green grid line here kind of up into space. And this is how it relates between my 1D and 2D spectra, because you can see in my HSQC, this grid line comes down and it's recognized this correlation here that it's picked, and it's sent a grid line from left to right, and it's then picked that peak in my carbon spectra. So this is a synchronized peak picking in action. It vastly saves on time, and it can save on errors moving between different spectra on different screens. And it's particularly useful if you have overlapping protons, because you can start picking your peaks in your HSQC. And I'll just show an example of this. Let's zoom in on here. We'll just reduce that so we can see the carbon properly. If I pick my signal analysis mode, I can start picking my peaks in my HSQC. And the integration is carried over to my proton. And the peak is picked in my carbon as well. So let's grab that one there. So it makes it really flexible how you want to do processing of your data. Let's shift back to the proton spectra, and we'll just complete the manual integration of this. So let's use the zoom tool here to zoom in. And so we can carry on with our manual integration. We can zoom in here to make sure we're picking all the peaks in this multiplet. And we'll just zoom in here in the aliphatic region and then complete this. So with this manual integration performed, you'll see this should carry over to my HSQC depth, so it's picked up all my correlations. And the only thing left to do here is go to my carbon, and then I can use this pick by level tool, and this will pick up all my quaternary carbons that haven't been picked up through integration in my proton on my HSQC depth. If I'm happy with how I've processed the data, I can then hit that auto assignment tool again, and then it will try and assign the atoms in my structure to my spectral data. And again, if I click on the options here, you can do this manually as well. So you can use the auto assignment, but you can also manually override or manually do it your own way as well. My match factor should be in my structure user table here, and my multiplet report has been created for my carbon and my proton. So we're happy with all the processing. The next thing we'll do is we'll show how to create some report templates in here. So I'll go up to pages and we'll see we've got a blank report. So last time I loaded up a user template. This time we'll go from scratch and we'll bring in items from the data set, starting with some 1D NMR item. And it's a case of clicking the item you want to have in your report. And then we click and drag a box in this report window. And this is all fully interactive at this stage as well. So you can change the zoom. You can change things like what you want to display. If I don't want to have my peaks there, I can remove them from here as well. So I can adjust these. I can add my data tables to the side, move these around however I want. So it's nice and interactive. We'll move that down to 7 so we can fit all that on. There we go. We can add extra pages. We can add our 2D data, for example. We can add our HSQC depth spectra. And we can play around with the settings there. And then maybe we want to add our carbon spectra and our carbon multiplet report as well. And if we go in here, maybe we want to change the format of that to suit a different journal. So that's everything that I wanted to show in today's webinar. Hopefully what we've seen is a nice overview here of Processor.js and the 1D, 2D synchronized peak picking. We've shown this particular data set proton carbon HSQC depth. This is used for a variety of 2D data. So if you have HMBC, COSIs, TOXIs, you can do all this processing in this format as well. So it's a nice tool to use for NMR data processing, but it can also be used for LC UVMS as well. So we'll just go to and summarize what we've done. Hopefully this webinar has showcased how you can use the Spectrus processor platforms to analyze all your spectral data in one interface. We've seen the desktop-based Spectrus processor, and we've seen the browser-based processor.js. And all this is designed to give you tools for your data processing, your data analysis, and your structural verification, so you can have more confidence in the conclusions you make. We hope that the software will accelerate your decision-making process, and it also provides the ability to quickly create comprehensive multi-technique reports. So I'm going to finish now, and I'll hand back to Barbara, and I think the next thing is some Q&A.
Thanks, Tom. That was brilliant. Thank you for your time to explain all the different functionalities. We've had quite a few questions come in actually over the course of the webinar. So some relate to desktop, some to Spectrus processor.js. So we'll try and get through as many of these questions as possible. If we don't quite get to your question, we will email you with the answer if we can. Even if we can't, we'll make sure that your question is answered. So one of these questions, and you might not know this off the top of your head, Tom, but someone has asked whether Spectrus processor is compatible with the Waters MSE acquisition that show LC-MS data in 3D. Oh, you're on mute, Tom.
So off the top of my head, no, I don't think we can show the 3D view in Spectrus processor, but we are compatible with a lot of Waters software.
Okay, and for anyone interested as to what data formats the software can handle, this information is available on our website, and if you would like a full list, please let us know at the end and we can email that across to you individually. Another question about Spectral processor desktop was, can you append NMR data to each LC peak within the application?
No, we can't in desktop processor. But what you could do if you wanted to is you could maybe not with the desktop, but if you have one of the workbooks, you can upload all your structural information with your different spectra to one record and have it contained that way. That will be a function available with one of the workbook suites, which is a slightly more advanced software than the Spectrus processor.
Okay, thank you. So yeah, if you want more information as to what other software that's a little bit more advanced we can offer, again, fill in the form at the end and someone from our account managers will be in touch. Someone's asked for the browser-based processor. Where are the data files stored? Is it locally on the cloud or somewhere else?
It can be, so for the browser-based, it's stored in your own company system. So we don't host anything. The setup can vary from installation to installation, but it's saved within the company that has purchased and installed processor.js.
Okay, thank you. We've got loads here, Tom. Let's have a look at another one. When the carbon-13 spectrum is being auto-picked based on a HSQC, does it deal well with coupled peaks, for example, to 31 phosphorus NMR?
That's a very good question. I don't have experience with myself with handling that data. We can handle 31 phosphorus NMR data within the software, but I don't have the particular experience with that data set. If the individual who's asked that question would like to supply us with some relevant data, then we can test it out for them and see whether it works or not.
Okay, so we've got your contacts there, so we'll get back in touch with you maybe individually again. Does Spectrus processor, I think it meant to ask, does it do MS2 and MS3 fragments as well in their assignments?
Yeah, it does. We can do MS2 and MS3 and MS4 if you have it within Spectrus processor.
Is that with the desktop and the browser based?
So yes, with both. Yeah.
Brilliant. Okay. Someone said thank you. What about degradation products? Is there any tool in a software capable of generating in silico degradation products?
So you're probably looking at more advanced tools for that kind of thing. We have an auto assignment feature which can fragment a structure and it can look at degradation products. That would come with MS Workbook Suite. That might not be quite what the question in the is after. The closest thing we have in terms of generating that would be a software package called MetaSense, which is used for metabolite studies. So what that would do is take the structure and it would predict certain metabolites that could form from that structure, but you can also ask it to predict degradants as well. And then it will look for the presence of those metabolites in your analytical data, your MS2 data.
Okay, brilliant. I think it should probably be worth just reiterating that Spectrus process is sort of our fundamental application. So anything on top of this, anything more advanced, will include all of the functionalities of Spectrus processor and more. So it's not that you're moving away from this, you are just getting a bit more when you upgrade to a different product. That's right, isn't it, Tom?
Yes.
Yeah.
So Spectrus processor is the, I guess, the base product. It
Yeah.
does the multi-technique processing, analyzing. It's suitable for most users, but we do have softwares that build on the base functionalities of Spectrus processor and provide some additional expert tools for, say, NMR users, mass spec users, or chromatography users as well.
Okay, brilliant. We've got someone here saying they're more interested in academic analysis of polymers, more specifically NMR and FTIR data. How, or do we have any more detailed analysis, or can we do any more for polymers? So how do we handle polymers?
It's quite a broad question. We do handle polymers data with a variety of customers. I think if that should be a case, get in contact with us and we can scope your use case in more detail and see whether we can help.
Okay, brilliant. So same as for a couple of the others. If you want to know more about sort of that specific use case, do fill in the form at the end and we'll be in touch directly. Is there a possibility to visualize not only the UV chromatogram, but also the radio chromatogram?
I don't know off the top of my head that answer. I've not encountered that particular data, so we'll look into that and come back to you.
Brilliant, thank you. Someone else, again, following on, said what happens if they only have FTIR spectra of an analyte?
That's fine. We can handle FTIR data within Spectrus processor.
Yeah, that should be fine. I'm just checking we've answered as many as we can. I think we have. My question is related to the theoretical mass calculation based on a molecular formula. Is there any chance to insert in a compound molecular formula a radioisotope?
Yes, we can, but I don't think that functionality is available in desktop basic Spectrus processor. That will be something that will come in the MS Workbook Suite, which is the processor plus the additional MS expert tools.
Right, okay, so it's a bit more advanced, but we could handle it with an upgrade. Okay, I think we've done all the questions. If there are any more, I will double check through, make sure we've answered everyone, and email anyone that's not been answered. But I think that's everything for now. No more questions coming through, so I think we can leave it there. Just on a final note before you all go, I just want to reiterate that there is a free 30-day trial of Spectrus Processor Desktop available, details of which will be emailed to you in a follow-up email with this recording. Okay, I can see a couple of questions have come in just as we're finishing up, so I will make sure that they are answered via email in due course. Okay, thank you everyone today for your patience and for attending, and thank you, Tom, for presenting. I think it was a really, really valuable walk through the software, both the desktop and the browser-based. And we hope to see you all again soon.